Okay, the third question. This one was probably the one that was kind of messed up the most in the test, and I can understand why. I think some of you just didn't spot the kind of easier route to take. So I'm going to start this question by actually splitting it up into to look like this. I just think it might help your understanding of it. So hopefully you guys understand that that is exactly the same as what I've just done there. So I've just kind of split it a little bit from the X just to get a clearer view. But it is the same question, like it's the same thing. So what would have made this question a lot easier would be to apply the rules of indices. If you apply the rules of indices, you may remember that, of course, in rule 2, if the bases match, you subtract. So before you even begin to go and actually differentiate, you can turn it into a much easier form. So this is what it looks like. And now again, remember, I haven't differentiated. I'm just turning it into something a bit more doable. So I need to do a point of inflection. Now, point of inflection literally means I have to differentiate twice. So I'm going to begin with my first derivative. So I'm going to begin by doing dy dx. Now, to do this, I can see that it is the product rule because I do have an x in each part. So I'm going to do u is equal to x and v is equal to e to the 2x to the power of 2x minus 1. So du dx is 1, dv dx. Well, you can go off to the side here and do this, but I'm sure after a bit of practice, you've learned that e always ends up the same, but you have to differentiate the power as well. Now, if you want to go to the side, change the color of your pen, substitute u in there, it'll give you the same outcome. I'm just going to skip that bit if that's okay, but that's your derivative. Now, because I'm using my product rule, again, I should be writing down my product formula. So again, you can just pause the video there if you want to write that down. I'm obviously just going to zoom ahead here just because I don't want to make the video too long. So that is my v times du dx, which is 1. So I end up getting x to e to the power of 2x minus 1 plus e to the power of 2x minus 1. Now, that's my first derivative. I can see here that I could factorize out the e to the power of 2x minus 1 from each one. And instead of saying x2, I'll just say 2x. It just looks a little bit better. This helps because when I go to do my second derivative, I can use my product rule here. So doing my second derivative, I'm going to let u is equal to the first part, and I'm going to let v equals the second. So I am still using my product rule to do my second derivative. So du dx is, so again, this is going to become 2 e to the 2x, e to the power of 2x minus 1. dv dx, well, this is actually just going to become 2. Now I use my product rule, so I use my u dv dx plus v du dx. So after I've done all that, I end up with 2 e to the power of 2x minus 1 plus, now if I multiply this out here, I would end up getting, no, actually, sorry, what I'll actually do is I'll factorize out the 2e to the 2 times e to the power of 2x minus 1. So when I do that, I'm left with 1 plus, and on this side, I'm left with 2x plus 1. So I end up with 2 times e to the power of 2x minus 1, and this becomes 2x plus 2. Now, to get my actual point of inflection, I allow, so this is my second derivative, d2y dx squared. I let that equal to 0. So that means my 2e to the 2x minus 1 is equal to 0, and so is my 2x plus 2 equals to 0. So here I end up with e to the power of 2x minus 1 is equal to 0, because if I divide the 2 over, that's what it becomes. And this ends up being E, so I have anything for 0, I can do as my 2x. Now, hold on. Sorry, that can't be 0. Yeah, that can't be 0. So my result is that's not, I suppose, viable. So what I do is I just continue ahead with this one. And I end up getting that x is -1. Now, that's my x value for my point of inflection. And notice it is only one point of inflection. So all I have to do now is get my y value. So to get my y value, I really just go back to the very start of the question, like I would normally do anytime I have an x value and I want to go back to get the y. So in the place of x, I am going to sub in my -1. So I'm going to put it there. I'm going to put it there. And down here, I'm going to put it there. So when I look at this a little bit closer, I end up with minus e to the 0 all over. This is going to just become e to the power of 2 take 1 is 1. Have I done that right? Hold on. E to the power of 2 minus x. Oh yeah, it's minus 1. I was thinking that didn't sound right. So that's e to the power of 3 because it's the minus there meeting with the minus here. So anything to the power of 0 is 1. So that's -1 all over e to the power of 3. So that then goes in the place of y, which is -1 over e to the power of 3. So obviously you guys got stuck and bogged down because you were using your quotient rule, then you were using the product rule, and there's nothing wrong with that, but it just became so time consuming that most of you just didn't get to the end. So you can see using your law of indices, I've kind of simplified that process.